of independent and dependent events in compound probability. So first we have here on the left side, the spinner is spun twice. Obviously, that's independent. You are not having any impact on the second spin from the first spin. Those two spins are independent of one another. This spinner has 8 total sections, meaning the first time I spin it, there's 8 different things that could happen. The second time I spin it, there are 8 different things that could happen, meaning my total number of combinations of numbers is 64. In the first example, I'm interested in spinning an even and then an even. I have 1, 2, 3, and 4 even numbers out of the 8 on the spinner. If I spin again, I am still interested in achieving an even, so I multiply 4 over 8 by 4 over 8, giving me 16 out of 64 combinations of an even followed by an even. And you could in your own mind list them. 2, 2, 2, 4, 2, 6, 2, 8, 4, 2, 4, 4, 4, 6, 4, 8, and so on and so on and so on. Any combination that involves 2 even numbers, even if they're repeated. We don't simplify these necessarily because it's kind of nice to see the total number of combinations in the denominator, so I keep abbreviating that TC, and the number of combinations that are an even followed by an even out of that total. If you simplified that fraction to 1/4, I think you'd lose some of the meaning of the fraction. So we're okay if we leave these ones not as simplified fractions. All right, in our next example, we have what's the chance of a number greater than 7 followed by a number greater than 6? Well, if I look at the spinner, there's only one number on the spinner that is greater than 7, so my first spin is going to be a 1 out of 8, and then my second spin is going to be a 2 out of 8 because there are 2 numbers that are greater than 6. So what's the only number that's greater than 7? That's 8, and then the 2 numbers that are greater than 6 are 7 and 8. So 2 out of the 64 combinations fall into that category of a number greater than 7 followed by a number greater than 6. Now we throw in an interesting wrinkle down here. What if you couldn't repeat a section? Well, you're going to see some minor changes in these fractions. Obviously, we're still going to start out the same with 4 out of 8 for the evens. However, the next time you go, you are not able to get the same even number again. So what was 4 out of 8 for 2, 4, 6, 8, the one you got can't happen again. So yes, the total will drop to 7, but also the numerator will drop to 3. Because those 4 even numbers that you were previously allowed to get, 2, 4, 6, 8, one of them, let's just say 8 for sake, one of them can't happen anymore. So then the second time you go, you're left with 2, 4, and 6, dropping us to 12 out of 56, a slightly lower chance. Same thing happens down here. Yeah, we'll start with 1 out of 8 because you're able to get the 8. But that then assumes that you've burned the 8 for the next spin. Since I can't get an 8 anymore on the second spin, I'm left with 7 as the only possibility, 1 out of 56. So slight changes to the denominators, definitely. Your total number of combinations goes down. But you also have to be wary of the chance that the numerator could change as well. All right, in our example on the right, our final example, we have a bag of marbles, and each marble cannot be chosen more than once. That is the dead giveaway that this is a dependent situation. We have 220 total marbles, and I cannot re-choose a marble. Now, this one I'm going to do a little bit differently because the numbers are going to get kind of big. I just want you to see the relationship between them. The probability of blue. How many blues are there? There are 30 out of 220. The next time I pull, I'm looking for yellow. There are 90 yellows, but I have removed one of the blues from the bag. meaning my denominator is going to be 219. The reason I wanted to show you this example is because if I then went yellow and then blue, just as you'd expect, I end up with the exact same value, 90 and 30 on the numerator, 220 and 219 in the denominator. It's just the numerators are backwards because I wasn't repeating one of the colors. I wanted you to see that this probability, my chances of going blue then yellow, were the same as going yellow then blue. So despite the fact that the denominator dropped by 1, it didn't change the result at all because I did not remove one of that color. Big takeaway message from these examples: anytime you have a situation where you're going to look for a dependent event, or you're looking at a dependent event, you're looking to change the denominators. You're making a statement about, I am changing the total number of possibilities. I am not changing what I expect to necessarily happen in the numerators. Numerators could stay the same, they might change, but I'm definitely seeing those changes in the denominator.